the Taylor's series. Those are the things we're going to be doing tonight. So we've always been telling ourselves that these two series, they depend on calculus, differentiation per se. They depend on differentiation. So it is from that we'll be doing the stuff. So may God help us. May God help us. So we have normal way of expressing functions, and we can as well have the expanded form. So to expand functions, in fact, sine x can be expanded. There are ways of expanding stuffs in a bracket, or let's say functions in a bracket. Binomials in most cases. So there is this binomial theorem. There is the Pascal's triangle. So there is Taylor's theorem. There is Maclaurin's theorem. There are many theorems we can use to expand stuff. So how do we use this Taylor's theorem is what we want to do now. And how do we use Maclaurin's theorem? Those are the things we want to get busy with tonight. May God be with us. So okay. So before we explain the Maclaurin's series, we are going to take Taylor's series first. It was created by Taylor. He was a scientist. So I don't know his first name. I happen to forget it. So he's telling us that we have a function f of x. At some point, let's say point A, f of x at some point A. Then he said the f of x can be expanded at that point A to be equal to f of A. We know what f of A is, right? If we had a function that is f of x at point A, then we can know what f of A is. Don't worry, we are going to give examples. F of A plus x minus that A. I'm writing the theorem for you now. This is Taylor's theorem. X minus A times f prime of A divided by 1 factorial. The reason I'm writing 1 factorial is that it is the first derivative. We know what a derivative is. Plus x minus A again squared. Now f prime of A. That is the second derivative of A over 2 factorial plus x minus A to the third power f prime of A, that is f triple prime of A, all over 3 factorial. Then to infinity until it gets to n, that open bracket x minus A raised to power n, then f of nth A, that is the nth derivative of f of A, all over n factorial. This is Taylor's theorem. This is Taylor's series. How do we use it to expand functions? That is what we're going to do now. This is Taylor's series. The first is you write your f of A plainly. Then you add it to x minus A times f prime of A, all over 1 factorial. Plus, so the thing, you don't need to cram it at all. It's not even series. It's about you using it, and you'll be very familiar with it. X minus A squared after that, then f. So since this one has become squared, so the prime becomes 2 as well, and the factorial becomes 2. Here, when it became, and the factorial became 3. That's exactly what we are talking about. Actually, it starts from here. But, you know, x minus A raised to power 0 gives us 1, and 0 factorial is 1. That is why this one is like this. So now, let us solve an example with this. I'm given a function that if f of x is equal to cosine x. Expand f of x or expand cosine x at the point pi all over 3. Expand cosine x at the point pi over 3. In this case now, my a is given. My a is given as pi over 3, and my f of x is given as what? Cosine x. So I just need to write the Taylor series and use it to evaluate, right? But I need to know f prime of x now, right? F prime of x is what? If f of x equals to cosine x, f prime of x is the same as dy dx. So what is the derivative of cosine x? Someone here, please tell me.
Minus sine x.
Thank you. That's exactly minus sine x is the derivative of cosine x. So please, for those of you that might not be very good at it, this is actually most things that come from Taylor's and Maclaurin series. They are mostly trigonometric functions. So try to know their derivatives. And in some cases, they will not be. I suppose everybody can use the normal series method, indices method, the power theorem to solve, to differentiate, or use any of the rules. So that means we've gotten f prime of x. Now, what is f prime of x? That is going to be the derivative of minus sine x. That is minus, the derivative of sine x itself is what? Anyone? Derivative of sine x is?
Cosine x.
Very well, sir. So that is minus, and sine x is cosine x. So this is the second derivative of f of x. We are asked to expand it. Let's say we are expanding it to the third derivative. So this is minus is here already. So the derivative of cosine x, as we've seen, is minus sine x. So this becomes minus sine x. We are differentiating, and that gives us plus sine x. So let's do the fourth derivative then. That's going to be the derivative of sine x, and that is cosine x. So we can expand it to the fourth term now, since we have it from f of x to f fourth of x, f fourth power of x, or something like that. I don't know what to even call it. So f of x is equal f of x at point A at point pi over 3 is going to be f of a. So what is f of a itself? F of a, we come back here, f of a means we will use pi over 3 to represent a, right? That is, and what is the function? That is cosine a. So what is a? Cosine, I'm supposed to have written a, but it's still fine. So cosine pi all over 3, that is our a. You know, we know that is our a already, right? So cosine pi over 3. And what is cosine pi over 3? I've told you anywhere that you encounter pi that is being associated with any of the trigonometric functions like cosine, tangent, cosec, sec, or sine. Just know that it's not going to be having the value of 3.142. It will be having the value of 180 degrees. So cosine pi over 3 means cosine 180 degrees divided by 3. So 180 degrees divided by 3 is going to give me what? 60 degrees. So this is simply cosine 60 degrees. I mentioned this in the last class. I think more beyond asked it. So this is cosine 60 degrees, because 60 is going to give me 0.5. That is my f of a. That is f of pi over 3. Now, what is f prime of a? That is f prime of pi over 3. I've already known the value of f prime of x, right? So I just need to know the value of f prime of pi over 3. That will be minus sine x is what? Pi over 3. This is the same as minus sine 60, right? We said pi over 3 is 60. If it is in the case of trigonometry. So this is now minus sine 60, and sine 60 is 0.866. So this is going to give me minus 0.866. Now, what is f prime prime of x, f double prime of x? That is given. So what is f double prime of pi over 3? That's going to be minus cosine pi over 3. And that is minus cosine 60. And we know that cosine 60 is 0.5. So this is minus 0.5. Then f triple prime of x is sine x. Therefore, f triple prime of pi over 3 is going to be sine pi over 3, which is sine 60, and that is 0.866. So f fourth prime of x is equal to cosine x. That means f fourth prime of pi over 3 will be cosine pi over 3. So cosine pi over 3 is cosine 60, and that is what? 0.5. So that is established. In that case, we are able to have all the values. Please, any question first? Any question before we proceed? Like, is there anyone that doesn't get this thing? Please let me know with your reactions. If you don't get it, show it. Nobody is answering me. If you haven't gotten it, I can explain again. Thinking about it, okay. Okay, what's your question, man? Okay. Mrs. Barade, let's hear from you. Mrs. Joyce, please speak out. Mrs. Joy.
Okay, the formula you wrote, because I was doing something before coming.
Please, before you go from, I just joined the class not quite long.
I will not come back. As for just joining the class. Okay. Because of the question Joy asked, I will come again then. So you can meet
my
your
own question is
fine.
If that formula is the general formula, like that's how the formula is.
Yes. It's not even about general formula. I don't want to call it formula so that you not be like you want to cram it. The thing is just, I don't know, it's just a very straightforward stuff. You are just going to write it. Since you are asked to expand a function at x equals to a, where a is a point, you just write f of x equals to f of a plus x minus that a times f prime of a. You've written it when it's not been differentiated at this point. Now it's already differentiated, f prime of a all over 1 factorial plus x minus a, you square that value, squared, times f prime prime of a, that is f double prime of a, divided by 2 factorial. That is because this one has turned to square. So this is definitely going to turn to 2 factorial. Now, my plus x minus a raised to the power of 3 over 3 factorial for f triple prime of a. This is, I don't want to call that in formula. It's something you can even write out by yourself. Use it to solve so that you understand it better. Use it to solve. That's it. So now we want to solve the problem that says f of x is equal to cosine x. Expand, okay, the question is expand f of x at point pi over 3. Expand f of x, which is cosine x. Expand cosine x at pi over 3. That is our question. So to use this thing now, we have to get f of a first. After getting f of a, we need f prime of a. We need f prime of a. So we've gotten all those ones now, and I don't want to explain that one again. So the video can definitely help you with that. I don't want to explain how it is gotten again, actually. It's just what we finished just now, and it is straightforward. So f of x at pi over 3 now, that is cosine x at pi over 3 would be f of a, that is f of pi over 3. What was f of pi over 3? 0.5. That's 0.5 plus x minus a. That is x minus, what is that a? Pi over 3 times f prime of a. What is of a? Then you come here. That's f prime of pi over 3. That is minus 0.866. what I'm thinking is I shouldn't use decimal point, but at the same time I can use decimal point. Nobody will sue me for that. But if I will not be using decimal point, that means sine 60 is square root of 3 over 2. I think I'll prefer not using decimal point. No those things. Let me say no those things. No, so but sine 60 is root 3 over 2. So minus sine 60 is going to be minus root 3 over 2. So I prefer to write it as that fraction. Minus root 3 all over 2 divided by 1 factorial. What I just did here is x minus a, what is my a? Pi over 3 times f prime of a. What is f prime of a? That's f prime of pi over 3. And that gives me minus sine 60. So sine 60 is always root 3 over 2. I think that was what I was supposed to have used, but I used the decimal point. Still the same thing. If you divide root 3, if you write root 3 divided by 2, you will get 0.8666. So we are multiplying it by that, divided by the 1 factorial that is here. Now plus x minus a all squared. So what is a? Pi over 3, that quantity squared, times f prime prime of a. F prime prime of a means f prime prime of pi all over 3. F prime prime of pi all over 3, which is equal to minus cosine pi over 3. That's minus cosine 60. Cosine 60 is always 1 over 2. So I don't know if I should, as I'm mentioning it now, you can be putting it somewhere. Sine 60 is root 3 over 2. Cosine 60 is always 1 over 2. So it is having minus, right? Minus. So minus 1 over 2 all over these 2 factorial. Then let's add plus x minus 3 raised to the power of 3. That's x minus a raised to the power of 3 rather. A is pi over 3. So raised to the power of 3 times f triple prime of a. What is f triple prime of a? That is sine pi over 3. That's sine 60. And sine 60 is root 3 all over 2, all divided by 3 factorial. Let's do the fourth one. The fourth derivative. So we have, so since the third one is x minus a raised to power 3 times f triple prime of a all over 3 factorial. Please, who can tell me the fourth one, the next one after that? Who can tell me what to write there? That's why I'm saying it's not a formula. We don't need to cram it. Who can tell me the next thing? Anyone, please.
It's going to be x minus pi over 3 raised to power 4.
Yes. Okay. X minus, I was thinking you would tell me the formula first. Okay. X minus pi all over 3 raised to power 4 times
1 over 2.
Very well. The fourth derivative of f of x, that is cosine pi over 3, that is 1 over 2. All divided by
4
factorial.
factorial.
So this is Taylor series. So Taylor series is not a hard stuff. This is Taylor series. We've expanded using Taylor series, but we should simplify to the simplest form. So this is, instead of writing this 0.5 now, I want to change it to 1 over 2 as f of x. So that is cosine pi over 3. That is cosine 60, 1 over 2. So now I have 1 over 2 plus, okay, because of this minus that is here. So 1 over 2 as the first term minus root 3 times x minus pi over 3 all over 2 divided by 1, right? But 1 factorial is still 1 plus minus 1 all over 2 times x minus pi all over 3 squared. Okay, what's the question, please?
Yes, I thought you said that one is 1 factorial and you
One
divide it by
factorial
two.
is because it is 1 times 1. So 1 factorial is 1 times 0 factorial. Like 2 factorial is 2 times 1 factorial. 1 factorial is 1 times 0 factorial.
Okay.
0 factorial is always 1. So 1 times 1 is 1. That's why I'm not bothering myself about it. So I have x minus pi over 3 all over this 2 factorial that is here. Don't let us remove it now because of this. This 2 is from this 1 over 2. And this 2 factorial is for this one. Plus minus, okay, it's plus root 3 times this x minus pi over 3 cubed all over, because root 3 over 2, right? 2 times this 3 factorial you are seeing here, plus 1 all over 2, this 1 over 2 here, open bracket, x minus pi over 3 raised to power 4 over 4 factorial plus to infinity. So this is now going to be 1 all over 2 minus root 3 all over 2 times x minus pi over 3 minus 1 all over, so 2 times 2 factorial, that is 2 times 1, and that is what? 2. I have 2 times 2, which is equal to 4, open bracket, x minus pi all over 3 squared plus root 3 all over 2 times 3 factorial means what? 3 times 2 times 1, and that is 6, right? So 2 times 6, that is 12, open bracket, x minus pi all over 3 cubed plus 1 all over 2 times 4 factorial. If you do it this way too, 4 times 3 times 2 times 1, you get 24. So 2 times 24 is 48, open bracket, x minus pi all over 3 raised to power 4 plus to infinity. We've expanded the bracket to the ultimate, expanded the function to the ultimate answer. Nothing more, unless simple expansion of bracket, x minus pi over 3 squared. And we don't need to expand that. So this is the first
final answer.
Now, yes, so cosine x at point pi over 3 is equal to this. More beyond, please. MB, let's hear from you. But I think he's not saying anything. So we've expanded the function. We used the Taylor's series, and that's how simple it is. Now, the Taylor series cannot be used in most cases to expand stuffs because of something. Because the Taylor series is always having at a particular point. So what if I want to explain something now? Becca, Anya, you raised your hand. Okay, she joined. Okay. So what if I want to expand something and I'm not given the particular point? And that's a function, a normal function that I'm willing to expand. Like expand sin x. That is when we now leave Taylor's series. Everybody, Maclaurin also did a work. But Maclaurin series was simply from Taylor series. MB, you're not saying anything. You are raising your hand. Maclaurin series.
Sorry, my network was bad. I had a question.
Okay. Yeah. You want to ask a question?
Yes, I have a question about the Taylor series.
Okay.
So, does it always have to end at least 4 factorial, or are there going to be points where we do up to 50?
Look at what I did. Have you forgotten that this dot means infinity? Yes, it goes to infinity. In fact, I might stop at 3. I might stop at something else.
So if you stopped at 3 in this question, will it have still been correct?
What do you say?
If you had stopped at 3 for this question, will it have still been correct?
It is still very, very correct. Still very, very correct. Did you get it?
Yeah.
In fact, if you stopped at 2, it's still correct. But you must put your 3 dots here. Nobody will not just
infinity.
And if you like, stop at 1. So that being the case, we should now say this is our Taylor series. I said Maclaurin series is just a brother of Taylor series. Even son is not even brother, son. Because Taylor series at a particular point is what we did now. Maclaurin series is Taylor series at point 0. Now let us write our Taylor series at point 0. That's going to be f of x at point 0 is equal to f of, when we said at point A, it was f of A plus the f prime of A. So now, it's now going to be f of 0 plus x minus, earlier we used x minus A, but it's now going to be x minus 0 times f prime of 0 all over 1 factorial plus x minus 0 squared times f prime prime of 0 over 2 factorial plus x minus 0 cubed times f triple prime of 0 all over 3 factorial plus to infinity plus x minus 0 raised to power n times f nth prime of 0 all over n factorial. What did we do here? We represented our A using 0. That is Maclaurin series. Maclaurin series is Taylor series at point 0. I am assuring you that this thing I just said is coming out of the exam. That Maclaurin series is Taylor series at point A equals to 0. Maclaurin series is Taylor series at point 0. It is still Taylor series we wrote out now, but we used point 0. Now, Maclaurin series is now reduced because as somebody that has sense, how will you be writing x minus 0 squared? It's now reduced to f of 0 plus x times f prime 0 all over 1 factorial plus x squared times, because you know that x minus 0 is still the same as x, right? F double prime of 0 all over 2 factorial plus x cubed times f triple prime of 0 all over 3 factorial plus f plus to infinity plus x raised to power n times f of nth prime of f of 0 over n factorial. So what did we just do? We removed the 0. I just removed the 0 now. And this is what we call Maclaurin series. So in the world, anything, you can expand anything using Maclaurin series. Even if you are doing first principle differentiation, and you want to expand the bracket of x plus delta x raised to power 8, you can use Maclaurin series to do it. In fact, part of what we will go and do later at the beginning of the textbook, that's why I didn't start from the beginning of the material, because we are still going to be using Maclaurin series at the beginning of the material. They already introduced it. They already used it. They didn't explain it. They already used it to explain something. In fact, at the beginning, that it will just get you confused. So that's why I purposely came here first. Let us explain the things we should explain first before coming to that. And fortunately enough, we were able to cover everything concerning series. And in fact, we are still talking about Maclaurin series and Taylor series now. But I wanted to ask a question earlier. According to what we've done, what type of series is this cosine x now? Is it a positive series or an alternating series? This is the series.
It looks like an alternating series.
And at the same time, it looks like series.
It's positive.
This is alternative.
Yeah, it's.
I beg now, all of them, don't stress me. I think say alternative how they look before. Now I say some minus dey follow and I beg no stress me. All of them look like. We will continue our stuff. So now let us expand the bracket. Let us expand sin x. I just said something now. You are not given any points now. You are asked to expand sin x. Since you are not given any points, you know you are going to use Maclaurin series. It does not say expand sin x at pi or at pi over 2 or at 60 degrees. So expand sin x, expand tan x, expand ln x. In fact, expand e raised to power x. They will ask all these things this way, and you just be simple stuffs. Shall we go ahead? Very well. So the thing is like this. To expand sin x now, we are going to use the Maclaurin series or Maclaurin theorem. We know that we need f of 0. We'll be using 0, right? So f of x is already sine x. So f of 0 will be what? F of 0 is equal to sine 0. And sine 0 is equal to 0. So f prime of x is equal to, we know f of x is sine x. So what is f prime of x? That is cosine x. So f prime of 0 will be cosine 0. Cosine 0 is equal to 1. F prime prime of x is equal to the derivative of cosine x. That is minus sine x. So f prime prime of 0 is going to be what? Minus sine 0, which is equal to 0. This is the best example of alternating series. Sine x. Oh my God. So f triple f3 prime of x, triple prime of x, is equal to, differentiate minus sine x. That's going to be minus cosine x. Minus cosine x. So f triple prime of 0 is going to be minus cosine 0. That's what? Minus 1. I'm taking it to the fifth point. F fourth of x, f fourth prime of x is going to be the derivative of minus cosine x. And that is minus sine x. And that is sine x. Therefore, f fourth prime of x is equal to sine 0, which is what? 0. So f fifth prime of x is going to be equal to the derivative of sine x, which is cosine x. So f fifth prime of 0 is going to be cosine 0, which is 1. Please, are we together, everyone? Hope I'm not just saying this. 1, 2. I want everyone to be with me, please. Thank you. It's nice there. I suppose everyone moves well with me. Very well. So we can now use this thing to expand sine x now. So sine x is going to be equal to f of 0. That is what? 0. Right? F of 0, that is 0. It is done here. Plus x times f prime of 0. That is 1. All over 1 factorial. Plus x squared times f prime prime of 0. F prime prime of 0 is what? 0 all over what? 2 factorial. Plus x cubed times f triple prime of 0 is what? F triple prime of 0 is what? Minus 1 all over 3 factorial. Plus x raised to power 0, which is what? 0 factorial, plus x raised to power 5 times f fifth prime of x, which is what? 1 all over 5 factorial, plus to infinity. So sine x is guaranteed to be equal to 0 plus x times 1, x all over 1 factorial. 1 factorial is 1, right? Plus x times 2, 0 over 2 factorial, that is 0. Plus x times 3 times minus x raised to power 3 rather. X raised to power 3 times minus 1. That is minus x cubed all over 3 factorial. Plus x raised to power 4 times 0, 0. Plus x raised to power 5 times 1, x raised to power 5 all over 5 factorial. At the end of the day, sine x is expanded to be x over 1 factorial, that is x, minus x cubed over 3 factorial, plus x raised to power 5 over 5 factorial, minus x raised to power 7 over 7 factorial, plus x raised to power 9 over 9 factorial, minus x raised to power 11 over 11 factorial, plus x raised to power 13 over 13 factorial, and that is the expansion of sine x. So this is the best example of an alternating series. It is an alternating series, and this is the expansion of sine x. Cosine x is as simple as these two. e raised to power x is even the simplest. Bro, what's your question? There is also ln x.
Yeah, good evening. So,
Yeah, bro.
yeah, it's understandable, but I don't know. Like, do we need to expand the factorial?
Okay, no. In these cases, it is more common to leave it this way. It is
Okay.
more common to leave it this way. In fact, the thing is like this. It is very common to leave it this way in the sense that before I even knew my chlorine series, all those things, then I had already known all these things offhand. Like I know the value of sine x, I know the value of e raised to power x, I know the value of cosine x, ln x. So even cot x, sine hx, cosine hx, that was because it was left this way. I just crammed it there before knowing all those things. Before knowing how to expand it that time, I was just like, let me cram it because I needed to use it. But later when I understood how to use it, so you can always leave it this way. You don't need to expand the factorial. If we expanded the factorial now, we'll be having x minus x cubed over 6 over 6 plus x raised to power 5 over 120. So like that, we start expanding. And it's going to become too bulky self and too cumbersome. So that's why we leave it in factorial form like this. We leave it in factorial form actually. So the reason we didn't leave this one in factorial form when we did Taylor series is that we have ordinary 2 here and we have 3 factorial here. Now say let's multiply them together, Jerry. Instead of having something that is not having factorial times something that is having factorial. I don't know if I should treat e raised to power x now and leave you to go and do all of that you want to do yourself. There is also hyperbolic trigonometry. I'm sure you know about that too. Sin hx is equal to e raised to power x minus e raised to power minus x all over 2. That is hyperbolic trigonometry. I myself introduced you guys to that a bit in the last semester or something. So you might encounter that too. To study new, it might not even come out of it. So let's end it here. Let me use e raised to power x and end it there. So that means we've been able to cover this one as well. We'll just do one simple thing in the next class and go back to the beginning of the material. E raised to power x, you are asked to expand e raised to power x. This one is very, very common. It is equal to x plus x squared over 2 factorial plus x cubed over 3 factorial plus is very, very simple and it is very common. So e raised to power x, you are asked to expand it using the Maclaurin's theorem. You know that f of x is e raised to power x. F of x is e raised to power x. So f of 0 is going to be what? E raised to power 0. Anything raised to power 0 is what? 1. So f prime of x is equal to what? what is the derivative of e raised to power x? Can anyone remind me? Is there anyone that still remembers it? The derivative of e raised to power x.
E raised to power x.
Very well. So it is still e raised to power x. So that means it is still, that's why I was saying it that time, like x squared over 2 factorial plus x cubed over 3 factorial, like that. It's just very simple. So that is f prime of 0 is still going to be what? E raised to power 0, 1. F prime of x is still what? Derivative of e raised to power x. That thing that will never change, irrespective of. In integration, it will not change. In differentiation, it will not change. It is e raised to power x. It is too noble. Like the noble gases, unreactive element of the periodic table. So e raised to power x is still the derivative here. And f prime of 0 will still be e raised to power 0, 1. I beg, I'm tired. If we keep putting it that way, triple prime of x is still e raised to power x. So f triple prime of 0 is still e raised to power 0 and it's still 1. So let us use the Maclaurin's theorem. Maclaurin's theorem says that f of x is equal to f of 0 plus x times f prime of 0 over 1 factorial plus x squared times f prime of 0 over 2 factorial plus x cubed over times f triple prime of 0 over 3 factorial plus to infinity. So what is f of 0? 1 plus x times f prime of 0, 1 all over 1 factorial plus x squared times f prime of 0 1 all over 2 factorial plus x cubed times f prime 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 of 0. That's still 1 all over 3 factorial to infinity. So this is 1 plus x times 1, x all over 1 factorial, plus x squared times 1, x squared all over 2 factorial, plus x cubed times 1, x cubed all over 3 factorial to infinity. So this is e raised to power x. It is equal to 1 plus x squared over 2 factorial plus x cubed over 3 factorial plus to infinity. It is a positive series. And let me tell you, if you did e raised to power 1 here, then you add all these things together, irrespective of the number of terms you used, even to the 10th term, you will still get the same answer, which is 2.781. So, that being the case, we were able to establish the two theorems. Please, any question first? If you understood it, just let me know, please. And if you didn't, let me know as well. Maybe I can just explain a bit more before ending the class. I'm supposed to end the class now. 1, 2. Please, I need everyone's response. All right, 3. May God help us. 4, bro. That being the case, I think I won't even wait anymore. I wish everyone the best. So the recordings will be dropped by King Smith, and thanks a lot, King Smith, for that. Or beyond. So I wish everyone the best. Let's have a nice time. Thank you.
Thank you. Remember when she submits to me very
Why are you racing? Sorry.
sorry.
God.